Big hint for the test. Okay, a lot of people will say the following. They'll read a problem and they'll say to me, I don't know even where to start. Okay, you have got to get used to that feeling. That's how a lot of AP problems will always feel. Honestly, when you get a meaningful career, a lot of things you'll do in your career will feel like that. I promise you, like when I would get to work each day, like I always had to sit and think, okay, I know I have these tasks to accomplish, but how do I accomplish them? Because a lot of times I was trying to fix problems that no one else had fixed. I'm trying to solve a problem that's not been solved before. Just learn to kind of find something to make progress with. As you make progress with one thing, you find something else, and you just kind of keep going. But don't feel like you're supposed to know how to do it when you first read it. You're not. So someone just read the problem, and as soon as you encounter a clue, just raise your hand and tell me what the clue is so you can write it down, and that will help us lead to another clue. Hopefully.
So let f be a function such that f double prime is less than 0. So that indicates that f double prime is negative.
Perfect. So you write it down. If you keep the clue in your head, it doesn't really help very much because your brain can only manage so many things simultaneously. If I write that down, it helps lead to another clue. So someone else, what does that lead to? Go.
F prime is decreasing.
So no, f prime is decreasing. And what does that lead to? Go. So f is concave down. So we've got a good start. Someone else. You don't need to read out loud, but just read, and when you find something that's helpful, tell me what it is. Like, we're not solving the problem, we're just trying to find things that will help us figure out how to solve this. For anyone? The points? It doesn't hurt a thing. So let's do that. I'll have you read me the points, Ellie, so I can draw them. And we know f is concave down, so I'll take advantage of that to draw just kind of a basic concave down shape. What's the first point, Ellie? 1.1, Next point?
1.2 and 4.38.
The next clue?
1.3 and 4.56.
And we'll stop there. Perfect. Somebody else, what else can we do? There's one other key piece of information in the problem that no one has addressed yet. Please.
It's asking about the f prime of 1.2.
So they're asking about f prime of 1.2. Now, okay, you need to have memorized that this symbol has two meanings. You have to know both meanings. Some problems will require one meaning, some problems will require the other meaning. Someone, what is the dual meaning of f prime of 1.2? Ellie. Slope of f, where? Perfect. Slope of f at a point of 1.2. So the graph you had me draw, Ellie, made me think about that for a minute and think, okay, so we're talking about the tangent slope at this point, because we are interested in the tangent of that green line. So this green line, f prime of 1.2, is equal to the slope of this line, which we don't know the value, but that's what they're talking about. Any questions? In fact, they're asking you to find this value. They simply state that that value is not known to be a specific number, it's just somewhere in some range of numbers. Do you have any follow-up to that comment? Now, big hint for the test. There are 3 problems on the test, pretty sure, that are testing you on this exact same concept. That does not mean that you'll see a problem that even looks like this, but it will test you on the exact same concept. You know, kind of deducing these sorts of clues. And then the next big step is this. They want to know something about the tangent slope of f at x equal 1.2. But we don't have any way of finding the tangent slope. So you on your own have got to come up with this recollection. Can't find a tangent slope? What kind of slope can I find? I can find a secant slope. So no one's going to prompt you to do that. You just have to think of it on your own. So let's go find some secant slopes. And this is kind of the idea we talked about last time in class. So we'll abbreviate secant slope equals. Someone help me. How do you find the secant slope between those points? Perfect. So rise over run. Somebody build on that. How do I find the rise? How do I find the run? Sure.
You can be 4.38 minus 4.18 over 1.2 minus 1.1.
Nicely done. So we find that the secant slope is equal to 2. Question? We can find another secant slope. Somebody? Jeff's in for 2. Great.
You do 4.56 minus the 4.38, and then over 1.3 over 1 minus 1.2.
Nicely done. Work all that out, turns out to be 1.8. We talked about this last time. If the red line has a slope of 2, the blue line has a slope of 1.8, and the curve is concave down, as you go from secant to tangent to secant, and secant, tangent, secant, it has to be a decreasing pattern. So it's not possible to know exactly what f prime of 1.2 is equal to. We can at least know about where f prime of 1.2 is. Someone tell me what it is. Where does f prime of 1.2 have to fit? Chance?
F prime of 1.2 is less than 2 but greater than 1.8.
Cannot say it better. Well done. Cannot say that better. That was perfect. That concept that we just described in this problem, you're going to hit at least 3 problems on the test that will verify that you are understanding this concept.
I'm sorry, how is it less than 2?
Let me ask you a couple questions. I hope you can see it.
Okay.
So first of all, because the curve is increasing, every tangent, no, it's not. Let me ask you a few things. See how good you are. Wrong! All right. I never saw this one, but my friend told me about it. I don't really watch The Simpsons, but he was a big fan. He said there was a Simpsons episode where, you guys know enough about The Simpsons to get the joke, I assume. No, yes. I do. How many people know who The Simpsons are? Oh, okay. So the dad, who's the really dumb one, Homer, he's like, he somehow ends up in a chain gang, like in a prison. And it's part of the responsibilities for the chain gang. They take them all to like the governor's mansion. Have you seen this one? Never mind. So they take them all to the governor's mansion, and they're making like serve for a party, like serve refreshments. And the prison guard tells Homer, he's like, "You're gonna play the piano." Homer's like, "I don't know how to play the piano." He takes a whip out, whips him, he's like, "Play the piano." He starts playing. He's like, all it takes is proper motivation. All right. That wasn't a very good joke, apparently. Okay, Jeff. Okay, every slope here is pointed upward.
Right.
So are the values of each slope going to be positive or negative? Positive, because they're sloped up.
Okay, I get it. Because so 2 is more positive and 1.8 is not as positive as slope of f prime 1.2. That's correct.
Does that make sense?
Yeah.
I told you it works.
Proper motivation.
Proper motivation. Anyone else? Perfect. Oh, please.
How do you know to find the
Great question. Okay, 3 for Brandon. That's something you really need to kind of have on a flashcard. I say flashcards a lot. It really will help you. Like you make a flashcard that says something like, just say, something like, if you can't find the tangent, look for the secant. I know it's kind of a weird clue, but it happens quite a bit on the AP test. The question, Brendan, is asking us to find out what this is. And we just don't have any way of finding the exact tangent slope. But once we find the kind of nearby secant slopes, we at least know that the tangent fits in a certain range. So there's nothing in the problem that even mentions the word secant slopes. You simply have to come up with that on your own. That's why I say if you have a stack of flashcards where you're okay, my flashcards are like all the little hints I've got to just remember as I'm taking the test. And you have something like, you know, when asked to find the tangent, if you can't, maybe find the secant instead. It really will help on a lot of problems. Is that, yeah, that's just what you have to do. So another clue could be this. You need to memorize, like I would have this on a flashcard. If a function is concave down, so I'd write that on one side. If a function is concave down, on the back side I'd write, then the tangent and secant slopes of the function will be decreasing. That can also kind of prompt you, Brennan, to start looking at secant slopes. So on the front side of the card I write, if a function is concave down, flip it over, it says, then the tangent and secant slopes of the function will be decreasing. And the thing that you have to be careful with, Jeff, is it's not, yeah, like what I have to pay attention to is the values.
Right, so that's what I'm saying.
Yes, like the lines are all going up, that's different.
Yeah.
It's that this value is 2, this value's got to be less than 2, this value's got to be less than that value as you progress across the curve. Yes. That's really, hey, what you were saying is the challenge of this unit, is they're simply testing you in Unit 1, do you understand the true meaning of all these terms? Like, do you really understand them? If all you had to do was memorize some stuff, we would have been done with this about the first week in September. And we just passed out the sheet, here, memorize this, and I'll give you a test on it. It's not how it works. You have to keep talking about it until it makes sense. So, please.
So just to clarify, so you said the tangent slope when a function is concave down, the values are decreasing.
The values of the tangent slope will decrease.
And the secant will decrease. Okay, just want to clarify.
Yes, and it will go one of 3 ways, hopefully. If you went from secant to secant, you'd see a decreasing pattern.
Yes.
So we saw 2 to 1.8.
Yeah.
If you went from tangent to tangent to tangent, you would also see a decreasing pattern.
Okay.
If you go from secant to tangent back to secant, you still see a decreasing pattern. And then, of course, the opposite is true for concave up. Right. I just don't feel like I need 2 flashcards. Because once I got the concave down or concave up flashcard memorized, my brain will remember the other one. It's just the natural opposite. So. Anyone else, please?
You said that there's no for
Oh, well done, Todd.
1.2, but you said you only say one meaning, which is slope of f1.2. What's the other?
Perfect, well done, 3 tickets. So f prime of 1.2 represents the slope of f at x equal 1.2. The other meaning is f prime of 1.2 represents the y coordinate on the graph of f prime at x equal 1.2. Is that cool? So the second meaning, Sarah, is f prime of 1.2 represents the y coordinate on the graph of f prime at an x coordinate of 1.2. What else? Okay. How many know the meaning of the word iterative? Raise your hand. Anyone know the meaning of this word iterative? Okay, the meaning is this. An iterative process is a process that you do repeatedly over and over again, okay? Learning calculus for most people is not a, I tell you something and then you know it. There are subjects that are that way. The teacher tells it to you, you just know it. Okay, calculus is more iterative. I explain something as best I can. You think about it, you work some homework problems, you come back, you ask me questions. I re-explain it once you've gone through that process, and it's that repetitive cycle is how you learn it. So just, if you get in this cycle this year, you'll be in good shape by May. Just have to keep asking and asking and asking. Kelsey?
So like just talk about vocab, like words for flashcards, what does relative mean?
Oh, perfect. Are you comfortable with the meaning of the word relative max?
Yeah.
And the word relative min? Perfect. So a function, any function has a relative max when that function changes from increase to decrease. Relative min is the opposite. So Kelsey, what they do is they don't want to have to write the words, where does this function have a relative max or maximums, and where does this function have relative min or minimums? So they just say extrema. It's both. Yeah, relative extrema means both. So. Does that answer your question? Anyone else? Awesome, next one. We're sitting here by 27, let's look at that. Actually, maybe not. 32. Perfect. Yeah, I jumped to 32 because the concept that is tested in 32 is nearly identical to the concept that was tested in 26. So I gave you a big hint that on the test, there will be, pretty sure, 3 problems that are testing you on the same concept. And it's the concept that I told Brennan to make a flashcard about, meaning that if you're not sure about the tangent slopes, go look at secant slopes. So again, somebody just glean a clue from this problem and tell me what it is. Find a clue, tell me what it is, I'll write it down. Okay.
So this is continuous, so that means there's no jumps over flashcards.
Whenever I read that a function is continuous, I relax a little bit. Helps. Don't have to worry so much about things. Somebody else? Hi, please. You're fine.
It says that f prime of 3 is equal to 2. So does that mean that it has to be a positive value?
It means that, well, it does mean that if you're looking at the graph of f prime, the y-coordinate at x equals 3 would be 2. It also means that if we're looking at the graph of f at x equals 3, the tangent slope is 2. But because it's only one point, I can't really extend that too much. Does that make sense? Perfect. Todd? That clue is more universal. Somebody, what does that really tell us? He said that f double prime is negative. That one's very helpful because it's for all x. Well, I guess at least 2 to 4. So f double prime is negative. How does that help, Ellie? So this is another problem where they're going to check and see if you truly understand the meaning of this statement. Do you truly understand what it means for a function to be concave down? That's what they're testing. Everybody with me? So somebody say back to the class, what does it truly mean for I just said it, I just all made a flashcard of it. What does it truly mean for a function to be concave down? Kelsey? Perfect. The tangent and secant slopes have to be decreasing. So I can graph these, but it takes kind of a long time. So I found a way to just kind of use the table. So from x equal 2 to x equal 3 sum 1, what would be the secant slope? I just use this little symbol to kind of remind me of secant slope because it's from point to point. It's not a slope at a point, it's between points. What's the secant slope here? 2.5. And Jeff, what's the next secant slope?
It would be 1.5.
So far, does this seem to fit the required pattern?
Yeah.
Yes, we're doing good, so keep looking. There's got to be something else. Someone else, just tell me this secant, just say it.
2.5.
2.5, the other one is 2. So these go pretty fast. Here it is 2 and 1.5. 2 and 2. Last one is how? 1.5 to 2.5. If one person, please raise your hand and make a comment if we've learned anything from this quick checking of all the different secant slopes. Lex?
You know, it can't be 0.
So give me a good reason why it can't be D, Lexi. So the secant slopes don't have a decreasing pattern. Perfect. So this one can't work. Same thing here. Any question? The last two are a little trickier. That's where you have to use this clue. Can anyone see how to use that clue? Oh.
So that's pretty much saying, right, like the tangent slope is 2. So it has to be greater and then less than 2. Because then it's right in the middle.
Nicely done. So that was that idea that we just talked about, that the pattern applies, the pattern for concave down applies to both secant and tangent slopes. And so A is the only one that works. We have secant slope of 2.5, followed by a tangent of 2, followed by a secant of 1.5. Let's look at this one. So if F is concave down, and I go from a secant to the next tangent, back to the next secant, I must encounter a decreasing pattern. This is not a strictly decreasing pattern. You see why?
Yeah.
Because of the 2.5 to 2 works great, but then a tangent of 2 followed by a secant of 2, that's not going to be a concave down.
Okay, so just say that the f prime of 3 equals 2 is the tangent slope of x, right?
At x equals 3. Perfect, perfect, perfect. Lindsay, please. Oh, right here, that symbol means that on the graph of F, at x equals 3, the tangent slope has to be 2. So the tables are showing a function F, so that's why I drew a line corresponding to 3. So from 2 to 3, we have a secant of 2.5. Right at 3, we have a tangent of 2. And then, is that how we get that? Perfect. Kevin?
Well, this is what I did, so I just like found the average of each one, like these other people do, like every time.
I would, let me say this back to everyone. If you are asked to find exactly what the secant slope is, sorry. If you're asked to find an estimate for the value of the tangent slope, finding the average of the two secants is a very effective and correct way to find a good estimate for the tangent. So that is true. Now, it won't always work that these two averages give you that exact value. The tangent isn't always right in the middle, so that's all. Please.
I don't really get why you're keeping it to f prime 3 equals 2 with the.
Let me draw a picture, it might help. So Sarah, help me. Take that first table, what was the first point? 2, 2.5. And we have a graph that's concave down, is that correct? So F is concave down. What's the next point? 3, and the next point? 4, 3.
Yeah.
Okay, so which problem is this? Number 3. Okay, the symbol F prime of 3 is equal to 2. On this graph of F, that symbol means that if we go to the next coordinate of 3, we will find a tangent slope whose value is 2. Have I answered your question? You good? Anyone else? Next one. 13 was not a sign.
Yes.
Yeah, it was.
Is that correct?
Yeah.
Correct.
13 was not a sign. No, you don't worry about that. Yeah, I'll never fool you and say, hey, you don't have to do this homework problem. Hey, guess what? It's on the test. I'm okay with teasing Jeff once in a while.
That would be very cool.
Yeah.
You have a good shot. Very self-assured. We will. All right, I jumped to 23 because again, 23 is testing on the exact same concept. So you've seen 3 different problems that test you on the same idea. That's the kind of thing you need to be prepared for the test. Someone please, 23, raise your hand and tell me something we can write down that will help.
Double prime is negative.
So Todd read that f has a positive first derivative. So we translate that into, just got to keep migrating towards more and more useful.
F prime is positive.
So f prime is positive. Somebody translate Jeff's statement into something even more useful than that.
If f prime is positive, then f is increasing.
Perfect. So f is increasing. Okay, that clue alone allows me to reduce the possible answers quite quickly. Someone comment on that. Kimmy.
You know, it can't be C, D, or E because those are all decreasing.
So the functions listed in C, D, and E are all functions that decrease. We need a function that increases. Perfect. Pause for questions. Somebody else, we need more clues.
Wait.
What am I doing?
So knowing that information, would that mean that f is concave down?
This clue doesn't tell me that f is concave down. Okay. Yeah, so don't make that mistake, but good question.
But it says that the negatives, the question says negative second derivative.
That does tell me. F double prime is negative.
Yeah.
If F double prime is negative, what else do you know?
And that f prime is positive. It's decreasing though.
That's better. F prime is decreasing. What else do you know?
That means f prime is concave down. Yeah, f, sorry.
There we go.
F is concave down.
Let me get back some tickets, man. I have trouble with his name, but you were straight up there with that. It's okay. Just gotta keep saying it's just sort of counts. Good work.
So real quick, so on those C, D, and E, so just because because it has to be increasing as the function goes down, is that why you could cross those out?
I don't know what.
I'm sorry.
So.
The F, C, D, F graphs of C, D, and E. So are they, so because they're decreasing as you go down, you can eliminate.
Yes.
Because
So
F is increasing, right?
Perfect.
Okay,
Perfect.
I just wanted to make that.
Now you're doing, that's a perfect question. Hey, the f function has to be an increasing function. So as you look at the f values, as x goes up, x always goes up. That's how we read the table. The f values are going down. So f is decreasing, doesn't match the code. Okay. Perfect. Asking for confirmation is really smart, so just keep doing that.
Okay.
Your brain, everyone's brain needs some sort of feedback. Needs someone to tell you, am I right or am I wrong? Or you need some way to figure it out for yourself that you're right or wrong. So asking for confirmation, do that as much as you want. What do we do now?
So now you can find the secant slopes.
So the secant slopes here have this pattern. The secant slopes here have this pattern. Which pattern are we looking for? You want the secant slope to decrease.
Got him.
So we're finding one that encompasses both.
Yes, because we're trying to find a function that fits both coders. Perfect. So if the problem were exactly the same, except that the clue they gave us was that f is a function of up, the correct answer would have been it. Also, a really good way to confirm your thinking, what you just said, like pick the opposite. It really helps. Read a book where it's on like the most effective ways to study. And like the highest one on the list was like compare and contrast, always picking your opposite, same, that sort of thing. Your brain loves connection. Your brain does not like things that don't connect to one another. I tease about this, but it's exactly why if I have had one of your brothers and sisters, I will learn your name way faster than if I haven't, because your brain wants a connection. And once I've had 3 or 4 or 5 of them, it's not even hard at all to remember them. Just the brain wants that connection. So, please.
Can you do that one more time?
You need to kind of guide me through it.
Why it's not A?
Okay. So are you comfortable why these 3 were not the answer?
Yeah.
Perfect. Are you comfortable that the function we're looking for must be concave down? Okay. You have a flashcard that says if a function is concave down, all of the tangent and secant slopes must be decreasing. You need a flashcard that says that. You have to have that memorized. So look at these. What we did, Hannah, is we found secant slopes from 2 to 3, and then the secant from 3 to 4, and then the secant from 4 to 5. And we noticed that that's what we want. The secant value is 4, then the next secant slope was 3, and the next one was 2. That's the pattern we're looking for.
So, like, why, because you did f prime is positive and f is increasing, so why did you write, like, f double prime? I don't know.
I'm not quite sure of your question yet, so.
Like the top part where it says the first derivative is positive, and the second derivative is negative. You're not understanding
Where that comes from. So that's a memorized statement as well. The question says we have a function f. If a function has a positive first derivative, those words are referring to the first derivative of f. The symbol that represents the first derivative of f is f prime. So that's why we know that f prime has a value that is always positive on the interval we're interested in. And down at this chart is just a little reminder that that means that the f function itself has to be going up.
Okay.
Is that what you mean?
Yeah.
You sure?
Yeah.
Sure.
Anybody else? Cool, next one. It's 17. Decent. It's not fast. Okay, 17 is talking about this situation. 17 is a pretty tricky problem. It's worded in a way that is easy to misunderstand what they're saying. You just have to go extremely slow. 17 says, I need someone to read it for me. I don't have it in front of me. Chad, read it slowly.
If the line tangent to the graph of the function f.
Stop there 1 second. So the line tangent to the graph of the function f. So here's the function f, and this orange thing is the line that is tangent to the graph of the function f. Keep going.
at the point 1,7.
Pause there. So the line is tangent to the graph of f at a point 1,7. So 1,7 is a point that is on the graph of f. All we're really doing right now has nothing to do with calculus. We're taking a reading test. Like we're saying, can you really read something that's written in a very clever and kind of technical way correctly? Perfect. Keep going, Chuck.
And passes through the point -2, -2, or -2, -2.
So it's the line tangent that passes through this other point. Perfect. And then the question asks us to find what, Chuck?
It's just asking us to find what f prime of 1 is.
F prime of 1 is equal to something. That's what we're trying to determine. Perfect. Heidi.
So when it's saying f prime of 1, does that mean at the x value of 1, what is f prime?
Perfect.
Is that what it's asking you?
So it's saying, look at the graph of f.
Okay.
Go to x equal 1. And at that point, what does f prime of 1 really mean, Heidi? So you guys said, say it.
Instantaneous slope.
It's a tangent or instantaneous slope. So they're asking for the slope of this line.
So would you really have to draw out the graph? Could you just do rise of the running interval?
You don't have to draw the graph to come up with the answer. The graph simply helps explain what they're really saying.
Okay, but like the way I looked at it, I understood when you said rise of the run from those 2 points. So
As long as it makes sense to you. Question?
Four over. Yeah, 4 over.
Oh, it's in that.
Oh, it's just at the top, sorry.
Oh.
It's bleeding into the blue screen there. Sorry about that.
So where did you get 9 from?
So, the slope of the line means how much does the line rise?
Yeah.
So here's how I do it. This is a point that is 2 points below the x-axis. This is 7 above. So if you go from 2 below to 7 above, how much did you rise? 9. Okay. Anyone else? Next one. 27. You need a flashcard. Flashcard should say, this is one of those, there's not a whole lot of flipping the flashcard, but you need this reminder. Tables only show selected values. There have been many AP questions that refer to tables, and where they fool people are people forget that the table only shows selected values. It does not show every value. If you can get your brain to remember, every time I see a table, I'm only seeing selected values, you're way ahead. It's a Danica's chart problem. Another word for your flashcard stack, polynomial. Yes, the function is a polynomial. Really good news. The function is both continuous and differentiable. And even better, every derivative is also continuous and differentiable. Even better, the shape of a polynomial is the nice shape that you're used to seeing. Polynomials look like this. It's the easiest kind of function to work with. So when a graph involves a polynomial, I know lots of things are going to be a lot easier.
Can you also say the definition of polynomial again?
So a polynomial, it's not really the definition, it's just some key things to remember about it, Jacob. So a polynomial is continuous and differentiable, and all of a polynomial's derivatives are also continuous and differentiable, which is kind of a common sense thing, because a polynomial has this kind of nice, smooth appearance. All right, so build Danica's chart, start checking the questions. And the first question says f is increasing. So my eye is drawn right here, and I notice a big problem. There's nothing written here. I have no way of answering this question. F could be increasing on the interval 0 to 2, but knowing F double prime does not give me any clue. So does it have to be true? No. I just move on. Questions? The second one, same thing. I can't tell that F is increasing using F double prime. I'm certainly not going to be able to tell if F is decreasing either. Questions? You need to have a flashcard that has the definition for a local maximum. Someone remind us. If I read on a card, F has a local maximum, and flip it over, that's when F changes. What should I be reading? You can have that on the card, but I have a little bit more, to be honest. F has a, you just got it backwards. F has a local maximum when F changes, increase to decrease, which is also where F prime is changing positive to negative. So same problem again. I don't have any way to determine if F prime is changing positive to negative because all I have is F double prime. You don't want to talk about any of that. These first three you just can't figure out. Okay? The next one. The next one is where my clue about remembering that tables only show selected values becomes very important. So the graph of F has a point of inflection at x equal 1. So I have a flashcard. Flashcard says F has an inflection point when, flip it over, what's written on the back? Kelsey? Perfect. So a function has an inflection point when the function changes concave up to concave down. So now I'm looking at a place on the chart that is useful. See back. Looking here, which means, this is useful. I need to see if I can identify that F double prime is changing sign. F double prime is changing sign. So the way they fool you is, from the table, it definitely appears that prior to x equal 1, the value of F prime is positive, and after x equal 1, the value of F prime is negative. That appears to be an inflection point on F. Questions? However, it doesn't have to be. Here's a graph of what F double prime might look like. Here's the x-axis. We have a point at x equals 0 and y equal 5. So this is 0, 5. And we have another point at 1, 0. We have another point at 2, -7. So it's 2, -7. And the last point doesn't really matter. Okay, the graph of F prime does not have to do this, because the table isn't showing every single possible F double prime value. So the graph of F prime could have done this. Savage, yes. Totally agree with that. Yes, tough questions, Sarah.
So the finer point of inflection, do you have that?
Great question. 4 tickets. With this graph alone, with this table alone, Sarah, you're correct. I cannot identify exactly where F has a point of inflection. There just isn't enough information. Now, I can answer this question because it says the graph of F will change in cavity somewhere between x equals 0 and x equal 2. And yes, somewhere from x equal 0 to x equal 2. Whoa. That was fun. Somewhere between those 2 points, the F prime value, F double prime values, they have to change sign. They have to, somewhere. But I don't know exactly where. So this one has to be true. This is a definitely true statement. Is that your question?
No.
Keep going.
I just mean so if they give you a graph or like a table and you took the F double prime is to tell where the point, like, where the point of inflection is, if you have to have the curve.
The trouble with the answer to your question is I have to say it depends. So in this example, no, you can't. You can't find exactly where the point of inflection is. If they added one clue, if they said f double prime has only one zero, that means f double prime has only one place where f double prime is going to equal 0, then I know for sure the inflection point on f would be at 1. But I can't do it without that extra clue. That's not the best answer because I can't just say yes or no. It really doesn't matter. Ellie. See, so you tell me, what is the definition for when f has a local maximum? Don't say yes. When f changes, increases, decreases. Look over here. When f is changing, increases, decreases, and all we have is f double prime, we have anything that correlates. We don't, so that's what it is. What else? What do you want? Are you ready?
So, could you explain C1?
Yes.
Because it goes down to 2 degrees. It's
What?
You're done. Good. How do you explain that? Oh, because it made Julie, why would it make sense? It made cross. I mean, and that's not a local.
Be careful. We're looking at a graph here about double prime. So the fact that this graph about double prime has a appears to be a local weight on a local maximum has nothing to do with this question. This one. Don't connect those two.
Well, no, I'm saying from positive to negative. We don't know if it crosses the x-axis.
True. We don't know if it's double prime crosses or not. That still has nothing to do with this one. So you have to memorize. Function has a local maximum. The function changes the increase. Okay. Well, if I don't have a picture of the function, I could also look at this. And identify if the derivative is changing from positive to negative, then I'll know that the function is changing from increase to decrease. But I don't have the derivative either. All you have is that double prime. So I don't have any information. So I'm pretty clueless here. I don't have any idea if either A to B is I just don't have any idea.
Okay, but you don't look at the